All right, now we look through approximate area. So let's say I have the function is y equal to x, y equal to x. And I want to approximate, I want to find the area from 0 to 3. Okay, I want to find this area. Okay, so this is the triangle. And we know that the triangle, the area of the triangle is 1/2 base times height, right? 1/2 base times height. And look like our base in this case have the length is 3, right? So we're gonna have 1/2, 3. Then what is the height? The height of that region is actually the output of the function. The output of the function. What is the output of the function? How do we find out? We just put 3 into the 2x. So then we're gonna get the height of the region, right? So 3 would be 6. So my height will be 6. The height will be 6. Right, from here to here is 6. So that will give you the area of the triangle will be 9. Okay, so now this is the regular shape, and we can use geometry formula to find out what the area is. But let's say if I have the shape is not regular, but it's something like this, then how do I find the area? Let's say this is the function f of x, y equal f of x, right? And I want to find the area from here to here. Okay, then how would I find the area here? So we won't have the geometry formula for some irregular shape. So that means we cannot use geometry. And the only way that we can find the area is use calculus. But before we look into that, to find the exact area, can we approximate the area first? Yes, we can approximate the area using the rectangular methods or rectangle methods. Rectangle methods. Okay, so we say rectangle methods. And what did that mean? That means we're gonna divide this region using to make it look like a rectangle. Okay, so I have the width of this. We have the, if we know the rectangle, if we have the shape of the rectangle, then the base right here we call the width, and we call that delta x. And then the height, this is gonna be the length. Okay, and the height or the length of this, it depends on what is the value of your width, and then you put into the function, you're gonna have the height, the length. All right, so depend on where your x is, you're gonna have the output of that function. So we have couple methods for rectangle methods because you can form the rectangle in 3 different ways. The first way that we may form is, for example, if I divide this region into 4 rectangle, then I'm gonna draw 1, 2, 3. Okay, but it's have to be equal rectangle. 1, 2, 3. Okay, 4 equal rectangle. Not 4 equal rectangle because they can be equal. 4 rectangle with equal width. Okay, so it means I want all this width the same thing. I want all the width the same. Okay, but the size of the rectangle will be different because it depends on the height of the rectangle, right? But I want all the width the same. So how do I find out what is the next value in each of these line right here? Okay, so it looks like I want to find the width of each rectangle. Then how do we do that? Since we divide them into 4 rectangle, so my width is called delta x will be the first value, and I call that is b minus a over n. Okay, so what is B and A in this case? So in this case, the B is 5 and the A is 1. So in order to find the width where you divide your rectangle, you're gonna take the last number minus the first number and divide how many rectangle you want to divide. So I'm gonna divide them into 4 rectangle. So I'm gonna take 5 minus 1 over 4. And clearly we can see that each rectangle will have the width of 1. So these have the width of 1, these have the width of 1, a 1, a 1. And then now how do I find the height? In order to find the height, that is something that we need to talk, right? Because to find the height, there are two different things, two different ways that we can do. The first way, we can use the height on these values. So I call this x1, x2, x3. And the height of this gonna be fx1 right here. If we use this point right here as our first point to make the rectangle, then this gonna be have a rectangle right here. Okay, so I make the first rectangle and I'm gonna continue using my second value, which is x2 to make another rectangle. So there's gonna be another rectangle right here. And then x3, I have one more rectangle. And then x4, which is 5, I have one more rectangle right here. So you can see all the point that I put that in blue. So these point is look like on the right of the rectangle. So we call this is the right end point. Right end point. End point. So for the right end point, this gonna be, we're not gonna check the first value. We're gonna skip the first value. We check on the second, third, fourth, and the fifth one. Okay. So you gotta have that's gonna be my height. So that my area for approximating this region will be the area. We say approximating, so that's why I use the curvy equal sign. So the first rectangle, the first one, is area of the first one. So I call that delta x, okay? Tell the length of the first rectangle, which is my f of 1. And then plus the area of the second rectangle, the base is also equal 1, but I call that is also my delta width, my delta x, right? Because all the width is the same, so I'm gonna call delta width x, and then f of x2. The second height is f of x2, and then we continue to do that for the third one and the fourth one. The third one is delta x, f of x3, and then plus delta x, f of 5, which is f of b. Okay, so turn out the formula to find the area of the under the curve, or estimate the area under the curve by dividing into n rectangle can be written by if you see all the term we have the delta x, because all the delta x is the same. So I bring it out to the front, and then we have f of x1 plus f of x2 plus f of x3 and then plus f of b. Okay. The reason why I put dot dot dot, because if I'm not divided into 4 rectangle, then you will have more x. And this will give you the formula where you apply the right endpoint to approximate area. Okay, delta x is b minus a over n, and then f of x1, x2, x3 is can be found by x1 can be found by taking the first value, which is a, adding the delta width, and then x2 will be a adding 2 times of delta width. Okay, so you're adding 2 of the 1, you're adding 3 of the 1. Okay, so total xn will be a plus n times delta width. Okay, so this is how you find x. Or the other way you can do it, you keep adding 1, the delta width, to the value that after your addition. So you're gonna have 1 plus 1 is 2, 2 plus 1 is 3, 4, and 5. Okay, so this is how you do. So this is just an explanation. When you look onto the problem, you will more clear on that. All right, now with the same problem, but instead of using the point the right point, we can also use the point on the left, right? The first value, we will take the first value first. If we take first value at the height, okay, then my rectangle will look like this. And then the second value will be x1, and then the third value will be x2, and then the fourth value will be x3. Okay, and the area will be approximate, and this is called left endpoint. The area to approximate using left endpoint will be delta x times. The first rectangle is the height will be f of a, so you're gonna have the first term will be fa plus fx1 plus fx2, so on to fx3. Okay. Okay, and your left endpoint will be the delta width time. You will include the first boundary and then keep going, and you left off with the last one. You don't put the last one into your the height. Okay, because you only use the point on the left. So this is the left endpoint, and the x1, x2, x3 can be found using this one as well. So now let's take a look at the estimation. So because we estimate, so we cannot 100% say the area will be our estimation. When we estimate, it should have some error. And you can look at this. To estimate this, we have a lot of error right here. Okay, we have a lot of error right here because you are actually overestimate a lot. But if you do right and left endpoint, you also have some error right here. This is gonna be underestimate. So we call this is overestimate. Depend on the problem, you will sometimes will have overestimate. And sometimes you may have underestimate when you use left endpoint or right endpoint. So it doesn't mean that when you use left endpoint, you will always have underestimate, because if you have the graph right like this, but increasing, and you use left endpoint, you will have the underestimate. But if you have the graph like this, okay, and you use left endpoint, you will overestimate. Okay, so in order to determine whether it's underestimate or overestimate, it's actually based on the concavity of the graph. Okay, concavity of the graph. So but anyway, no matter with left endpoint or right endpoint, you will still have some error of approximation. To make it more closer to your actual area, we can take the average of the left endpoint and the right endpoint. So the average will give you a better approximate of that. So you're gonna find the area using the right endpoint, plus the area for using the left endpoint, and divide by 2. This will give you a better approximate and closer to an actual area. Okay, and we will take a look at the example.